All right, good.
Okay.
First step for me is to check the temperature, because the nerve conduction studies are highly temperature sensitive. So we keep the temperature above 32 degrees Celsius to compare with normal values which are available. Mark the areas where we're going to stimulate and record from. For a carpal tunnel, we're going to zoom on to the median nerve, but we always want to compare with the ulnar nerve, so we have to mark everything for that. So it looks complex, but it's a very simple marking technique.
You want to measure the distance because the speed is
Correct. We need the
distance
velocity.
divided by time.
Yeah. So the standard coloring. So this is the ground electrode for the green. Active electrode is the black, and this is the reference electrode, the red. So same concept as any electrical system. Okay, here we go.
You feel a little twinge.
Oh, we already, you can see the screen there. We already have a response there.
And this gives you the amplitude and the speed.
Correct. So the x-axis will give you the time, and the y-axis will give you the amplitude of this. Here we go. So we already are seeing it. Okay. You can see why we like the peak latency. You see the shock artifact is coming too close. But we have a way to sort of rotate the electrode and get it. So now these are two different sensitivities. So I'm going to change the sensitivity on this. So now 50 microvolt is the gratitude.
And the same now.
Right. So now they are same. And the ulnar is 48.4 microvolts, which is very good. And the 1.6 milliseconds is the peak latency. The difference is only 0.2. So this is very good. At least it tells us that she most likely has no carpal tunnel problem. Now here, the nerve is very deep, so usually it's more difficult to see it. Here we go. Oh, we got it. So I'm going to make sure it is supramaximal by going a little further. Okay. The difference between the two, and if you know the distance, which we have here, 190 millimeters is the distance difference. And 3.2 milliseconds is the time between the two. So that gives the conduction velocity in this area here, in the forearm. Here we go. So I can feel the ulnar groove here. I'm going to go as low as I can, because we want to get a good distance here at the cubital tunnel.
So measuring not only the median nerve, but actually right down to the digit.
Right, yeah. It's pure sensory, that's the thing about it. It's very easy to pick up because the nerve is very close to the skin.
Do you want me to turn a little more?
Drum and stern. Stern and drum.
Just move the hand. Okay, you gotta put the needle in. It's already in. So, first thing to notice that it's silent. The muscle doesn't make any noise when it is put in. When I move it, it will make a little bit of crackling. A little bit of crackling. That's the normal insertion activity. And then what we do is to gently bring the arm up. So that,
it's firing.
Yeah, so it's a very mild contraction. Just a few units near the needle are contracted. Try to zoom in. And you can study it. You know, these are called biphasic potentials. You can measure their size. Yeah, it's about 200, so 1 millivolt
That's
size. 1 millivolt size. The duration is about 5 to 10 milliseconds. So this is very normal motor unit. And then push. We can also study like this. You know, it's already recorded for a certain amount of time, so I can play back and study it also.
I see.
Yeah, as usual. So now we'll see a full contraction. Okay, she's increasing the force, so you will see the rate of firing becomes more, and there are new units. New units will come in the picture. Push up. So now there are several units, and really push on. A large number of units, but they are all small units.
And the people want to look sick.